All right, you right? Here we go. Exercise 9C. I want you to copy down this general formula that you will be seeing quite often. Here we go, copy this down. Y equals m times x plus c. Let's go. Y equals mx plus c. I want you to copy this down. M times x. Mx plus c. Just one c.
You write everything.
Yep. Yep. Here we go. That's what I want you to copy down at the moment. Exercise 9C in your exercise book. Let's go. Eyes and ears towards the board. Focusing. 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 I would like you to copy down these notes. They're important for next year. So, exercise 9C, let's go. I'm going to describe M and C in the most sort of simple way to start off today. And then as we're going through the chapter, excuse me, year 8. Remember my 3 rules. Please don't speak while I'm speaking. I find it disrespectful. Okay, you had your time. You had a bit of 4 MTs, but now I actually do want you to copy this down. So you got y equals mx plus c. What I'm going to describe today is just how to do. As we're going through the chapter, as you get more comfortable with it, I'll start describing why this is true, but you are just going to write these key notes. These terms are going to be used quite often next year, and I know even till my year 11s, we're actually moving on to this topic where we're studying the gradient. So it all starts here. So you learn it in year 8, you practice it again in year 9, and then you're meant to have mastered in year 10. By year 11 and 12, we use the gradient to study a lot of parts of mathematics, and it comes back to the basics. So I'm only going to teach you for this year. I'll see how far I can push your understanding. It can go all the way up to year 12, or we can just start as simple as the idea of what a gradient is. So let's start off. Your task for today, the goal is that I'm going to teach you how to find the equation of a straight line. So you found that in the previous exercise, you were to use a rule. So they gave you a rule, for example, something like y equals x plus 1. And then you use the table to then answer what the y values could be. Then you plot the coordinates. Okay, so each one is a coordinate, and most of you should have gotten a straight line, right? What we're doing today is that you don't have the rule, so they don't give you this rule, and you are meant to use the table and then figure out what the rule should be. Now, to figure out the rule, there are 2 key features of these particular straight lines. First thing is, I'm going to start writing down a few rules, and I want you to pick up some patterns here. Okay, see if you can see a pattern to it. So I like to use Desmos, and you can all access Desmos on Google, and it's a really cool one where you can start playing around with the equations. But let's start off. We got y equals, and I'm going to do x plus 1. Okay, so it is a straight line. So it turns out that all the coordinates, no matter what the x values are, the y values will end up being a nice pattern, and it's a straight line. I'm going to do another one, and I want you to see what's the difference between the equations y equals x plus 1. What do I change that changes it so that it doesn't become a straight line anymore? So let's try, I might do negative x minus 10. Okay, let's see if this is still a straight line. Yes, it's still a straight line. What if I gave you y equals to x squared? Okay, now that's not a straight line.
That's a circle.
That's well, we call it a parabolic shape, which is kind of like a bowl kind of shape. What if I gave you y equals to a fraction now? So maybe I'll do half, so 1/2. and then I say times, oh sorry, not times, I'll just do x. That's still a straight line as well. Now I just want you to just have a look at the moment. What's the key thing out of the three equations? X plus 1, negative x minus 10, x squared, half times x. What is the common pattern that makes it a straight line? What did I do that made it not a straight line?
Squared it.
I squared it. So one of the key things, have you noticed that all of the x's, they don't have an extra power to it. It's only a power of 1. It's x squared changes it, but then this is still x. Even when I added a fraction to it, it didn't matter, because when the x is by itself, that is purely a straight line. There's no other x's with an x squared or anything like that. That becomes a straight line. So you can come up with any formula you like now, as long as you only have one x, and it's only x to the power of 1, it will be a straight line. So I can make up another one right now. I can do, let's say, I'll play...
Want to make a circle?
There is. Circle is x squared plus y squared is equal to 9, for example. It's a circle. Okay.
What
Which-
change it to equal to 10?
Yeah, it will still be a circle.
So it's x squared something plus y squared.
Correct. And you can even move this y squared if you wanted to. So I can move the circle up or down. Say I put up 10, it moves, say 3, it moves the circle up or down. Okay, but that's something that you can learn when we get to year 11 and 12. But for now, you're learning what we call linear equations. So you're looking at straight lines, and the first thing you notice that all the equations you have will always be just an x. So it means that I can do something like this. I can do y equals to 0.1, guys, thank you, minus 2 times, and as long as I put an x somewhere, and there's only one x, it will be a straight line. Okay, so it doesn't matter what it is, but there's a pattern here. And that pattern follows what I got you to write down over here. This is what we call a general linear equation, meaning that you can make up any number. The numbers I made up before, all I changed, listening, all I changed were these two numbers. I made sure I had an x. I made sure that the x is to the power of 1, not a squared, not a cube. As long as it's x to the power of 1 and there's only one of the x's there, all I changed was the number that's multiplying to x and the number that I'm adding or subtracting to it. That's all I'm doing. Okay, and you will always get a straight line. That's why in your exercises, I can look at exercise 9b as an example. Can you see all the patterns here? All of these equations, I know they're all straight lines without even plotting them. I know because I can see the pattern. I can see that that is an x, doesn't have to the power of 2, has a minus 2. But what am I timesing x? Just 1. What am I timesing x here? I'm timesing by 2. What am I timesing x here? A negative 3. But all of them follow the same pattern. There is a value that's multiplied to x, and there is a separate term. And sometimes there's no separate term. Okay? But the key thing is, what makes it a straight line? We found out that the pattern is as long as you have one x value. Now normally, I would describe even further and why that is true, but at the moment, that's all you're memorizing. Okay? So, in your notes so far, you should have an understanding that that's how you tell it's a straight line. Second thing, I want you now to focus what happens with that c value. Okay, so this is what I want you to see. I call it the y-intercept, or that's the name for it. But I actually want you to look at what happens when I change the numbers for the plus c. So remember, m, I'm going to highlight it again, m is the number that's multiplying to x. C is the number that you're adding or subtracting to it. I want you to see what happens when I change that number, okay? So here we go. We go back. Desmos, I'm going to delete all of these because then it gets less confusing. Here we go. I'm going to delete them all. Now,
Can you zoom out in Desmos?
I can zoom out, yeah? Like that?
Right. Does the line go on forever?
Yep. Because it's a pattern. We're just saying whatever x is, add 1. So you can have x is 1,000, add 1, the y value would then be 1,001. So you've got all of the x-axis number line, they go on infinitely, therefore you can have infinite coordinates. So hence, the line goes infinitely. That's why when you were sketching, I told you to just continue on, don't just stop where the 2 points are, because a straight line is infinite because the x-axis is infinite and therefore the y-axis is infinite as well. So you have infinite possibilities. Okay, so the pattern is, it's a straight line. Now let's see what happens here. I'm going to zoom in a bit more so you can see the pattern a bit clearly. But here we go. Let's have a look. 0 all the way here. Now notice, I want you to notice this part. When I had a +1, I want you to see, we call it the y-intercept because this is the y-axis, the vertical axis. Notice where it's crossing. It's at 1 as well. Now watch what happens when I change this value. So when I change it to 2, all right, we'll do 2. Can you see that the y value now, the y-axis intercept, when it crosses the y-axis, boys, thank you. When it crosses the y-axis, it is also 2. What happens if I change it to a -2? So if I change it to a -2, here we go. Then, yes, you're right. Notice here, -2 is where it cuts. Now what I'm interested in, what is the coordinates of the ones we just described? 1, 2, and -2. What's the coordinates at each of those points? 0. What's 0? X. This is one of the first things I want you to write as part of your notes here. We notice that on the y-intercept, doesn't matter where, the x value is always 0. So I'm going to write here, I want you to write on the note on the side, x is always 0. Okay, so the coordinates is always 0 and whatever the y value is. So if this is 0c, that's what the point is always going to be. Whenever you put a c there, no matter what number you put it, it turns out to be, and it doesn't happen for every equation, just for the linear equation, that when x is 0, that c value will be the value of the y-axis intercept. Okay, so that's what you're going to memorize at the moment. I'm going to show you, we can keep playing with the numbers and it will always be where it cuts the y-axis. Okay, so let's try it. Let's go back. So I'm going to go back to the Desmos. Watch. We can pick a number. We can say plus 0.5. So I put a decimal now. Can you see that it's actually crossing at 0.5? That's a positive 0.5. If I changed it to minus 0.5, whoops, 0.5, you can see it now crosses at negative 0.5. Those y-axis values always occur at when x is 0 and the y value is whatever that is. There's a pattern to it. Okay? So that means on your table, when you're doing exercise 9c, see, we're looking for when x equals 0. See here, if I had to look at this table here, this is the x values. We said that the y-intercept, or the c value, is when x is 0. Now, if we have a look at this table here, we happen to have x equals 0. The y value is negative 2. So what this tells me is the equation has to be, when you have mx plus c, this is the value. Already in the equation, I know it has to be minus 2. Straight away. Because that's the pattern. The pattern is that when x is 0, whatever that y value is, that is my c. And we call that the y-axis intercept. Okay, so if you plot it on your Cartesian plane, you notice this is always on the y-axis. Because when x is 0, the y-axis intercept is going to be at negative 2. That has to be negative 2. Now I know that's minus 2. The only thing I don't know at the moment is I don't know what m is. If I can figure out what m is, I've got an equation. If I've got an equation, I can go into Desmos, type that equation, and it'll give me a straight line, and it'll have all of these coordinates ready. Okay? So now I'm going to teach you. So you learned how to find c. How do you find m? Okay, now m is a pattern. We did this briefly in exercise 9b. Some of you actually picked up on the pattern as well. I'll show you. Now, we call it the gradient, not I call it. We call it the gradient. Notice I wrote y over x. This is the pattern, so I'm going to write here, this is the pattern for all the y values. You're going to find what's the pattern for the y values, and down here is the pattern for x values. So let's have a look. Some of you might have figured out when you were doing exercise 9b that you didn't actually have to follow the rule all the time. You realized there was a pattern from each y value, and the same thing with your x values, there was a pattern. So let's have a look at the x values. Now, x values generally have the same pattern for most of the exercises. What's the pattern for the x values? Going from -2 to -1, -1 to 0, 0 to 1, 1 to 2,
Plus one.
Up by one.
plus 1, up by 1, or technically on the x-axis to the right by 1. Okay, because it's x-axis, so left or right. So here we can say add 1, add 1, add 1, add 1. What's the pattern for the y values?
Up by
Add three.
Add by 3. From -8 going to -5, I'm adding 3. Or from here 1 to 4, you're adding 3. So I can see there is a consistent pattern. Add 3, add 3, add 3, and I can get to my next points. So when I'm trying to find my m value, okay, the pattern for the y, we said pattern for y, add 3. Pattern for x, add 1. So if I write that, this is what it'll look like. Add 3, add 1. So I'm going to write it over here. So what is my m value? I've just figured out it is add 3 over add 1. And remember, it's the number that's multiplying to x, which is 3. So together, what is my equation? 3 divided by 1, right here, 3 divided by 1 is 3. 3 times the x is 3x. And we know it is minus 2. This is my rule. And that's what you're training in exercise 9c. We knew how to find this. It's when x is 0. We knew how to find the gradient by looking at the pattern. Okay, so you can look at the pattern on the table. You can look at the pattern on a graph. Okay, you're finding what is the x value pattern and what's the vertical y value pattern. Okay, so let's plot this now on Desmos. And what I want you to see is how these points play a role. Okay, because all of these are points. So we now have 3x minus 2. We know this is a straight line. There's only one x. There's no powers. There's a number that's multiplied to x. And we've got a c value. Yep.
How did 3 go over 1?
So this is based on this is just me telling you that a gradient ratio is y over x.
Oh, it's y of x.
Yeah, and that's a common one too. So most of us, when we write our coordinates, we write x, y, and then when it comes to gradient, this is what happens in year 9. A lot of students will flip it around. So we're used to writing x on the top and the y on the bottom. You'll find that next year you'll get into that a bit, and you get better at it over time. But that is a common one. So most students will write x on the top and the y on the bottom. Traditionally, we do it the other way around. So it's y on the top, x on the bottom. Yeah.
But how did we even get m plus c?
So this is a general rule. So we're just using that to start off with. Usually I go really deep into why this is true,
What did
but
the question tell you?
no. So you're meant to sort of know that if,
That's just if.
yeah,
For everything.
for straight lines. So they'll tell you, normally they'll say this is a linear pattern or prove that's a linear graph. If it's a linear graph, we know all straight lines will have to follow y equals mx plus c. And we know that as long as you know m and you know c, these are called parameters. Once you know m and c, you then have a rule. Okay, so let's have a look at this on Desmos. I'm going to show you on Desmos. Let's go back to Desmos. 3x minus 2. Here we go. 3x minus 2. This is our equation. Now what I think is beautiful here, and hopefully you can see, I'm going to copy this as well. Let's examine what's happening here. Okay, so I'm going to go back to our OneNote and I'm going to analyze with you. I want you to see that in exercise 9b, you were doing parts of what Desmos is already doing. Here we go. Let's have a look. Can you see in the coordinates here, we said when x is 0, y is -2, right? I want you to look at the graph and we already see right here,
-2.
x is 0, y is -2. But not only that, all the points, listening, all the points here that you wrote down is existing on this graph. So let's say 1. You got 1, 1 over here, so you should have a coordinate somewhere that says 1, 1 that sits on that straight line. That straight line should cross 1, 1. So let's have a look. This is where 1 is, so I'm going to zoom in. You can see here, this is where 1 is, and this is where y is 1. Can you see? It sits exactly 1, 1. Now, you know how we said before the pattern there was a pattern. Listening, eyes and ears towards the board. We said there was a pattern. Number of x across and the number of y's up, right? We said +1 across and +3 up. What I want you to see here, can you see from here to here, that's 1 across. That's on the x-axis, 1 across. And then from -2 to get to this point, can you see it's 1, 2, 3. See, I'm going to draw it again. You can see it's 1, 2, 3. This is your +3 that you were talking about. This is your +1 on your x-axis. This is your y value that you were figuring out. And this is your x pattern. So we do a ratio, and if I go deep into it, we talk about ratios. But at the moment, I'm just giving you the gist of it. But that is where the mathematics is coming from. There's a pattern in a straight line. It will always follow that ratio. It will go 1, 3, 1, 3, 1, 3, 1, 3 infinitely. Just like how you would notice the pattern, it will just keep adding 1s on the top and adds 3s on the bottom. Now, when you're doing this exercise, most of you will start picking up on how to find the equation. Question is, what happens when you don't have a 0? See, if I want to find c, y equals mx plus c, we said when x is 0, I can then work out c. But now in the table, if I don't have 0, how do I do this? Can anyone think of a solution?
It's 1.
How did you know, James?
Because if you work at the pattern, you just keep going.
Very good. Now I want everyone listening to this point. Listening? Eyes and ears towards me. Thank you. Thank you. Now this is key. Okay, so I want you to listen to what James just said. We know that C occurs when there's an x that's 0. Now we don't have an x that's 0, but doesn't mean that that's it. You can follow the pattern. See, you know the pattern is add 1, add 1, add 1. So if you want to go back to 0 for the x value, keep subtracting 1s. So you need to go, to get to 2, I need to subtract 1. To get to 1, I need to subtract 1. To get to 0, I need to subtract another 1. So you can see that to work backwards, I have to subtract 1, 1, 1, 3 times. So that means, what's the pattern on the bottom? Because if I can figure out the pattern, I can then figure out what that value for 0 is.
-2.
Very good. So -2. This is +2 actually. +2 to go this way, -2 to go that way. Very good. Okay, boys. Thank you. Eyes and ears towards me. Rule number 1. Don't speak while I'm speaking. You've got -7, -5. We know that's adding 2, adding 2, adding 2 again, and then finally adding 2 again. You would then get 0. So -5 add 2, -3. -3 add 2 is -1. -1 add 2. And that's why James said the y value had to be 1. That's how you can find C. So C has to be +1. How do you find M? The pattern. The pattern was moving across was -2. And that was add 1. So I would write -2 over 1. So if you were to write it together, it's y equals -2x plus 1. That's my rule.
Why is it +1? So x equals the one on the bottom.
Yep. This is the pattern for y, pattern for x, and that one is calculating 0. So we were going backwards. Remember how we were plussing 2, plussing 2, plussing 2?
I remember, but it doesn't make that much.
Okay, it means that I will have to sit down with you to do the pattern with you. Okay, but that's how you do that kind of problem. So like I said, this one was easier because you had a 0. When you don't have a 0, you have to calculate it. You have to go backwards until you get the 0. Later on, you don't actually have to do that. There is a better technique to finding them out all in one go, but at the moment, I can only teach you the most basic level, and then we'll use algebra. That's why chapter 5 and 7 was important. And we will use algebra to solve it more efficiently. Rather than using tables and counting, it takes a lot of effort. Algebra is simple.